Right, in this video we're going to solve a pair of simultaneous equations that have complex numbers in them. With these sorts of problems, you've just got to be very careful when you're working through things, not to misplace signs or write things down incorrectly. It might sound like a fairly standard thing to say, you should do it all the time, but you have to be doubly careful when you're working with complex numbers, I find. Right, we've got two equations, A and B, and we want to solve them simultaneously. So what I'm going to do is I'm going to look to solve them simultaneously through a process of elimination, and I'm going to look to eliminate the variable w. So in other words, I need to go and take equation A, and I'll multiply equation A by 3 plus I, and I'll take equation B and multiply that by 2 minus I. So what happens to our equations when I do that? Right, to begin with, I'm going to have 3 plus I times 1 plus I z plus 2 minus I times 3 plus I w is equal to 3 plus 4i times 3 plus I. That's a bit messy. Let's tidy that up. If I go and look at the coefficient of the z, I've got 3 times 1, which will give me 3. I've got I times I, which will give me I squared. I squared is minus 1, so I've got 3 minus 1. That's going to give me 2. I look at the outers, 3i. I look at the inners, I've got 1i, so that'll give me plus 4i. That's the coefficient of the z term. I'm not going to bother with the coefficient of the simplifying coefficient of the w term because I've set it up in such a way that they will both be the same. If I take a look at the right-hand side, 3 times 3 gives me 9. 4i times I gives me 4i squared. So that's going to be 9 minus 4, which is 5. Then I've got 4i times 3, which is 12i. 3 times I, which is 3i. So 12 plus 3 gives me plus 15i. So that's what equation A is going to work out to. Equation B, well, I've got my 2 minus I. I'm going to multiply that by IZ. I've got my 2 minus I. I'm multiplying that by what's there, 3 plus IW. And on the right hand side, I've got minus 1 plus 5i multiplied by 2 minus I. Again, I'm just going to tidy up what I've got here. 2 times I, that's quite simple, that's going to be 2i. Minus I times I is minus I squared, and that will end up as being plus 1. Z. I'll keep these as they are. 2 minus I, 3 plus I. And on this side, what have I got? I've got minus 1 times 2, which is minus 2. 5 times minus I, 5i times minus I, that's going to be minus 5i squared. Minus 5i squared is the same as plus 5. So I've got minus 2 plus 5, which is going to give me 3. 5i plus 2 times 2 is 10i. 1 times minus 1 times minus I is going to give me plus I. So I'm going to end up with plus 11i. So I've got my two sets of equations now. Let's put them together so that we can see them in a little bit closer detail. Just deal with them in different colors so we can separate them out. So 2 plus 4i z plus 2 minus I, 3 plus I W is equal to 5 plus 15I. That's equation A. And the second equation is going to be 1 plus 2I Z plus 2 minus I 3 plus I W is equal to 3 plus 11I. So that is equation A, that is equation B, adjusted. And in order to eliminate my one variable, I'm going to say A minus B. And what am I left with now? Well, I'm going to have to take away this pole bottom line from the top line. And I've written it so that I've got the real components matched up with the real components, the imaginary components matched up with the imaginary components. So I've got 2 take away 1. That's going to leave me with 1 plus 2I Z. I know the W is going to go because I've set it up like that deliberately. Now I've got 5 minus 3, which is going to give me 2. And I've got 15I take away 11I. That's going to give me plus 4I. And I want to get Z by itself. So I'm going to divide both sides by 1 plus 2I. The right-hand side over here, I'm going to take out a common factor. I'm going to take out a common factor of 2. I've got 1 plus 2I. And I'm going to divide that by 1 plus 2I. And so I get that Z is equal to 2. So there's the first part of my solution. I've got that Z. So with Z equal to 2, I go back to my equations and look to see which one I'm going to work with. I reckon B is going to be the easier equation to work with. So let's give myself a bit more space here. What have I got? I've got equation B looks like this. It says I Z plus 3 plus I W is equal to minus 1 plus 5I. And I know that Z is equal to 2. So in other words, I've got 2I plus 3 plus I W is equal to minus 1 plus 5I. And now if I pull this, if I take away 2I from both sides, over here I'm going to be left with minus 1 plus 3I. And on the left-hand side, I'm going to have 3 plus I W. So all I have to do now is go and divide both sides by the 3 plus I. So I divided that by 3 plus I. And as we've done before, I need to rationalize this. So I'm going to multiply top and bottom by 3 minus I. And let's see what that brings us. Well, on the bottom line, I'm going to get 3 times 3, which is 9, minus I squared. So in other words, it's going to be plus 1. So I know that my denominator is going to be 10. Up on the top, I've got these two things being multiplied together. Minus 3 times 3 is going to give me minus 3. 3I times minus I is going to give me minus 3I squared, which in other words is going to give me plus 3. Then I've got my inners, which is 3I times 3, which is going to give me 9I. And then minus 1 times minus I will give me plus I, so I've got plus 10I. And so that simplifies down to just I. And so we have the solution for W is that W is equal to I. And so there are two solutions. Z is equal to 2 and W is equal to I.